Hello, this is Jarod and Connor in Don Ruba's Electronics 100 class, and today we're looking at our darkness sensor. Take it away, Connor.
So how this works is whenever you cover this up, whenever the sensor is dark, these lights light up. How the whole circuit works is power goes through this timer circuit, which every second goes on and off, which then powers this relay. And real quick, just a little detour how this relay works is there's a little coil up here. When that's powered, that creates a magnetic field. And then down here is a set of contacts with an armature connected to it. When this is turned on and that magnetic field is created, that armature closes. And when it closes, one path is completed so current can flow through it. The other path opens up so current can't flow through it.
And you can see that with the diagram over here. So that first part where we have the coil that's getting power and generating the magnetic field, that'd be from the output of the timer circuit straight through here and then out to ground. Whenever that's getting power, it'll change it from its normally closed position to its normally open position and close that instead. So in this case, if it were normally closed at red, it'd be changing over to the orange LED.
And then kind of going a little bit further at the circuit, this over here is a wheatstone bridge, this little mess of resistors. It's getting power from right here. How that works is, that's what makes this a darkness sensor, because normally this senses light, but the way it's set up is so that way when it gets dark, these lights light up. Normally, when it's dark, they would turn off. But how that works is when you cover it up, more resistance is created by this path, and so because that's the path of more resistance, current won't go through there. Instead, it'll go through here, the path of least resistance. And then it'll go through these lights, which are hooked up to this relay, which again, going back to those contacts opening and closing, which if maybe you can hear that little clicking, that's what that is. So that's closed, open, closed, open. Same thing over here. Closed, open, closed, open. And that's how those are going back and forth, just through that little armature, like right here. Closed, open, closed, open. That's what's causing those to go back and forth.
Now, in this same diagram, this would be the representation of the wheatstone bridge. The wheatstone bridge is made so that there's an imbalance of resistance. This imbalance would be because of our photoresistor here. If that were all 1K ohms resistance, these would all be the same. There wouldn't be any power going through here if they were all the same.
It would just go through the resistors and straight to ground. It wouldn't go through these side paths.
Right. So yeah, this just increases the resistance when it's darker, and then the power will go, instead of through here, it'll go through the relay, out through through the relay, out through these lights, out through this side of the wheatstone bridge, and then to ground.
One quick thing to note about the wheatstone bridge is technically everything from here, through these LEDs, all the way back here, that's technically inside here, but it's just a lot easier to have it represented going outside, just because trying to fit all that in here would be a bit of a pain. So yeah, that's all inside the bridge technically. This is going across.
Just a connection from the left side to the right or the right side to the left. Well, that's all.